you're into podcasts about ghastly crimes or hip-hop rhymes, there's always something new to discover on Spotify. With a mix of originals and many of the world's most popular shows, listening to podcasts on Spotify is easy. Just open the app, tap Browse, and dive into their growing library. Subscribe to your favorites, including our entire archive, so you'll never miss a show. You can also download podcasts for those moments when you're up in the air or going underground. Podcasts on Spotify are streaming right now. Go check them out.
Get in touch with technology with TechStuff from HowStuffWorks.com.
Hey there and welcome to Tech Stuff. I am your host, Jonathan Strickland. I'm an executive producer here at How Stuff Works, and I love technology, and I love science fiction, and I love fantasy, and I love the technology of science fiction and fantasy worlds, and you guys do too. I was just talking with one of the folks on our team, and she was telling me about how the Tech of episodes are some of the favorites of people out there, and so I wanted to do another one. And the day this show publishes should be the day that Star Wars The Last Jedi hits theaters in the United States. And that, coupled with a book that I received in the mail that is titled The Physics of Star Wars, written by Dr. Patrick Johnson, inspired me to do another one of these Tech of episodes. This time, of course, the Tech of Star Wars. And I say another Tech of Star Wars because way back in 2010, holy cats, 7 years ago, Chris Paulette and I tackled the concept of lightsabers and how they work, both within the Star Wars universe and also how the actual effects were done in movies. We even talked a little bit about whether it might be possible to ever build a similar device in our world. I did a rerun with an update for that episode in 2014. I also did a show back in 2013 titled TechStuff Leaps into Hyperspace to talk about the faster-than-light travel tech of Star Wars. I'll touch on both of those things again in this episode, because I think it's safe to say that without the concepts of hyperdrive and especially lightsabers, you can't really call it Star Wars. So we're going to touch on those, but we won't go into as much detail as those previous episodes. So if what I say to you is interesting and you really want to learn more, I recommend you look at the backlog of Tech Stuff episodes and find those, and you can check them out. So let's get some basics out of the way before we jump into any of the technology. Now, I'm fairly certain almost all of you out there have at least heard of Star Wars, if not seen all the major movies. Some of you are probably hardcore fans who have seen all the movies, read the comic books, you've watched the television series, the animated series, you've got your own DVD of the Star Wars Holiday Special, which George Lucas famously wanted to destroy. You might have all the toys. You might know the names of every single character, no matter how minor or how briefly they appeared on screen. But this episode is going to be for everybody, so if you are a hardcore fan, just let me get through this next little bit. So the first film came out in 1977, and after it came out, when it first came out, it was just called Star Wars. After it came out, it was later given the subtitle Episode 4, A New Hope. After 1983, it seemed like we were only going to get 3 movies. It was just going to be a trilogy. That would be Episode 4, A New Hope, Episode 5, The Empire Strikes Back, and Episode 6, Return of the Jedi. Originally going to be called Revenge of the Jedi. So for years, we thought that was all we're going to get, at least officially. We did get all these other supplemental pieces of media, including comic books. There were some specials. There were a couple of Ewok movies. The less said about, the better. And then you had the sort of splintering of the Star Wars universe. So you had what most people consider canon, which is the stuff that appears in the films. That's all the official, this is definitely part of the Star Wars universe stuff. And then you had everything else that was in the expanded universe that might or might not be part of the official Star Wars universe. Some things might get incorporated into stories. Some things might be completely disregarded. And there are also contradictions within that as well. But generally speaking, fans like myself consider the things in the films to be canon and everything else is apocryphal. So it might be true, but there's nothing until it's in a movie. It's not law. Fast forward to today, and now we've got a dang Star Wars movie coming out every single year. Whether that's a good thing or not, I'm going to leave it for some pop culture podcast. That's not for me to say. I'm just going to look at some of the science and tech within the Star Wars universe. And that's where I turn to Dr. Patrick Johnson. Now, as I mentioned a moment ago, I received a book written by him titled The Physics of Star Wars. It has the extremely cute tagline of "May the F equals MA be with you." F equals MA being the formula to show force. So may the force be with you. I'm sure you all picked up on that. The book covers lots of different aspects of physics and technology. It covers stuff like time dilation and planetary physics. So there's a ton of information in the book. It's really easy to read, and it's laid out in a way where it gives you the context of the technology or concept in science within the Star Wars universe. It then explains how that must work within the Star Wars universe. And then there's a section about how close are we able to match that in our world, whether it is a process or a technology or whatever. And I really enjoy it. So if you get a chance to check it out, you should. So I use that as my primary source of research for this episode. I'm going to focus on the tech. Obviously, I could talk a lot about the physics and stuff if I really wanted to. And some of the physics information will come into this, but this is tech stuff, not stuff to blow your mind. So we're going to focus mostly on the technology part, knowing that technology is really just applied science, right? You just take that scientific knowledge and you make it into something. So where to begin? Well, I've done a full episode on it, and I even did a rerun with some updates, but I think you have to begin with lightsabers, because I would argue it is the most iconic out of all the technologies that are related to Star Wars. It was something that really struck a chord in viewers, and it makes sense. You've got a hero who's wielding essentially a magic sword. That's what George Lucas called lightsabers. He didn't really refer to them as lightsabers that much in casual conversation. He'd talk about magic swords, and the bad guy's got a magic sword, so you get to have these great, cool sword fights. Which, again, in the early versions of Star Wars, that original trilogy, they're a lot less acrobatic than later lightsaber duels, but still pretty darn cool if you happen to be a kid growing up and watching it for the first time. Now, in the world of Star Wars, lightsabers are a Jedi's weapon. Jedi are the force-wielding warriors that are able to control these mystical powers. Other people can try to use lightsabers, but there's at least an implication there that Jedi are the only ones who are really able to be proficient with them, that perhaps an affinity with the Force is necessary for you to be able to use a lightsaber effectively and not, I don't know, lop your own limbs off. Lightsabers are never really described in great detail in the films. We know that Jedi build them because we know that Luke's father built a lightsaber than Luke has, and then Luke himself has to go and build a lightsaber later on in that original trilogy. But it doesn't really go into the details of what makes up a lightsaber in the movies. Now, the expanded universe definitely addresses this, and some of that element gets kind of leaked into the movies in little casual bits and pieces, but again, it depends on what your tolerance is for apocryphal versus canon. There's more information like a power source, essentially a battery pack, a crystal that focuses energy, an emitter that allows the blade to come out of the hilt. But really what you just need to know is that a lightsaber is a weapon, a blade made out of some form of luminescent energy. So the blades tend to be about 3 feet long. That varies depending upon the Jedi. I'm sure Yoda's is more like 2.5 feet long. The blades can be found in various colors. Jedi colors tend to be blue or green, although Mace Windu famously wields a purple lightsaber. And Sith sabers, as in the bad guys, dark Jedi, well, let's not get too technical. Sith and dark Jedi are not synonymous, but Sith sabers tend to be red. And lightsabers can block blaster fire. We'll talk more about blasters in just a little bit. And they also will collide with other lightsabers. You can have a duel with someone else, and if your lightsaber contacts their lightsaber, there's physical contact. as if you were holding like a physical blade and it came into contact with someone else's physical blade. So that presents itself some challenges when you try to figure out how to explain how this stuff actually works. Lightsabers can cut through metal, they can cauterize wounds, they are clearly hot. The blade itself is hot, or else it wouldn't make any sense. Various sources in the Star Wars universe refer to them as things like laser swords or plasma swords, which are two very different things. And both of them present very complicated issues if you want to talk about an actual handheld weapon that can form a blade that you can then use to cut through a metal door or lop off a snotty little teenager's arms. I guess Anakin at that point was actually probably older than a teenager, but anyway. So if it's a laser sword, that's tricky because we're not really good at getting light to stop at a specific point 3 feet out from the hilt of an emitter. Imagine having a flashlight and turning it on and just thinking, well, I want the flashlight to only extend 3 feet and then I want it to stop. How do you do that? How do you get the light to not continue on? One way you could get around this is if you had some sort of system that would hold a mirror about 3 feet out from the hilt, from the emitter on your handle. And it would reflect the light back down into the emitter and allow that light to bounce back and forth between emitter and mirror. But the movies don't seem to have that mirror. It's kind of a moot point. You can actually see when a lightsaber is sort of pointed directly at the camera, there's a point of light there. So clearly there's not some sort of dark spot. So it doesn't really work in that case. Plus a laser that's strong enough to cut metal and cause massive damage would require a great deal of power. The lasers you find in laser pointers are not strong enough typically to cause very much damage, although you can buy some that are strong enough to maybe set fire to some matches or maybe even do some more severe damage to stuff if it's left on a flammable surface long enough, if you've concentrated the light on that spot long enough. But if you want something that's going to be so strong that can do that sort of instantaneous damage, you're talking about a massive requirement for power, and you would need a really big cooling system, something to keep all of that equipment cool so that you could continue to use it. That's probably not something that you really want with a handheld blade system. So lasers also another big problem. They can't physically stop other forms of energy like blaster fire or lightsabers from passing through the blade. Again, if I have a flashlight and you have a flashlight and we swing our flashlights in arcs so that the actual beams would come into contact with one another, we don't feel any resistance. The beams just pass right through. There's no collision there. So if a lightsaber is made out of a laser, then you don't have this physical contact element that lightsabers clearly have in the movies. So we can't really describe it as a laser. And keeping in mind, yes, these are fictional movies, obviously, right? It's fantasy. If you really want to get down to it, it's more of a fantasy film than a science fiction film. And there's nothing wrong with that. We're just talking about if we wanted to make one in the real world, could we do it? So let's say that, all right, well, lasers are clearly a no-go. What about plasma? Plasma is a real thing. We can make plasma. Plasma being ionized gas, not the component in our blood, but an ionized gas, it's the most plentiful form of matter in the universe. Stars are made of plasma. And ionized gas just means that the gas is made up of charged particles. The atoms have had electrons stripped from them, which means you've got free-flowing electrons within that gas. You've got charged particles flowing within that gas. Typically, the way we do this is that we can put it under a lot of pressure and heat it up a whole bunch, and that strips the electrons from these atoms and causes them to move like crazy. When you add heat to material, you cause more atomic motion. And so this is very fast-moving particles within a gas, a big ionized hot gas. And we're talking about hundreds of thousands of degrees in Fahrenheit, like 230,000 degrees Fahrenheit, something like that, in order to get the gas at a temperature where you're stripping it and you've made this ionized format. That temperature is definitely high enough to cut metal or to cauterize wounds. There's no question about it. If you did get plasma, then you could cause some serious damage. But you also wouldn't be able to hold the lightsaber, because it would be as if you're holding a handle from which a substance that is the temperature of the surface of the sun is coming out. You would have to have some sort of incredible protection so that you don't immediately get burned by it. Not to mention there'd be other forms of radiation besides just heat that you would have to deal with potentially. So you might be able to contain the blade using electromagnets, because an ionized gas, having a charge, it does respond to magnetic fields. In fact, that's actually a big problem, because if it comes into any range of any magnetic field of consequence, that magnetic field's going to bend the blade. If you're on a planet that has a magnetic field, for example, Earth has one, then that's a problem immediately. The magnetic field of the planet alone would distort the blade to the point where you wouldn't be able to have an actual sword pop out of the hilt. You might be able to have it stop where you want it to using electromagnets. So unlike lasers, where it's just going to shoot out and keep going, using electromagnetism, you might be able to create like a cylinder, essentially a loop of plasma flow, so that you have kind of this glowing torch of plasma, and you could simulate having a blade that way. However, just like lasers, you wouldn't be able to use this blade to stop things from hitting you like other lightsabers or blaster fire. Dr. Johnson in his book describes it like this. If you think of plasma is really kind of a soupy sort of substance. It's a soupy substance of particles. So if you had two lightsabers in a duel, it would be like two blades of soup hitting each other. They don't clash, they would just gloop in. Also, because they would both have these electromagnetic fields around them, instead of it bouncing off of each other, they'd more likely meld into one. You would have the electromagnetic field twist in such a way where it becomes one field instead of two, and you would end up having your two blades merge into a single plasma mess, which is more like something that happens in Spaceballs than in Star Wars. But yeah, it would not work the way it does in the movies. And so really the final verdict is that lightsabers are works of fiction through and through, with only the most tangential relationships with real gadgets and science, though we do have stuff that can do some really impressive cutting or cauterizing. It's just that it's not in that laser sword format. It's less visually impressive than that. So we do have stuff that can do some amazing things, but it's not like a light sword that'll really impress people when you turn it on. It certainly doesn't make that cool voom voom noise. Blasters, kind of a similar story. In Star Wars, blasters are guns. They could be cannon, or they can be handheld blasters, rifles, that sort of thing. They fire out brightly lit projectiles. When I was a kid, I just thought of them as laser guns. I just thought, no, it's a laser gun. Even though they call them blasters in the movies, I think in the scripts they refer to them as laser guns, at least in some of the early screenplays. They look a little like laser beams. They're truncated. You get these kind of like tiny dashes. So think of them maybe like as much as a meter long in some shots, but usually it's less than that. And they're just coming out of these guns, and you can see them. You can see this distinct dash-like line. They don't move like laser beams, so they can't really be laser guns, because if they moved like laser beams, they'd move at the speed of light, which means we wouldn't be able to follow their progress. We'd see if they were on or off, but we wouldn't be able to see them move across a place because light travels too fast for us to perceive it that way. If you turn on a flashlight, you cannot actually follow the beam as it leaves the flashlight and heads out into the environment, for example. You know, if you turn it on, it looks like the end of the flashlight. Let's say that you're pointing at a wall that's 50 feet away. You turn the flashlight on, it looks like the light has instantaneously come on as far as onto the wall. So you didn't actually see the light travel from the flashlight all the way to the wall. It goes way too fast for that. Clearly, blasters do not fire projectiles at that speed, because we can actually follow them with our eyes. In fact, not only can we follow them, but characters can and do dodge them or block them with lightsabers. So Jedi will use their lightsabers to block blaster fire, And in at least one altered scene, we see a character dodge blaster fire from just a few feet away. That would be the awful retroactive edit to A New Hope, which I don't like, and I don't know why you even brought it up. It was tacky of you to do it. You should know that that particular edit, it really upsets me. Han shot first. So like lightsabers, blasters are not really comparable to any real-world technologies today. I mean, if you think of it as something, again, like a plasma weapon instead of a laser weapon, you run into some of those same problems I was talking about with lightsabers. Mainly the idea that if you come into contact with any magnetic field at all, it's going to warp the fire. You can't reliably hit anything, which I guess could explain why stormtroopers are so bad at shooting stuff, because the weapons they use are being affected by magnetic fields of other materials, and therefore they are random, the way Obi-Wan refers to blasters, random and crude, unlike a lightsaber, which would be just as random in the face of magnetic fields if it too was made of plasma. Lasers are used in weapon systems today, but they're more frequently used for guidance and aiming. There are some militarized lasers that can cause damage, but typically these are ones that are mounted onto large mobile stations, like a trailer that you would tow behind another vehicle, or sometimes mounted to a militarized vehicle, because they require so much energy to operate, and they're so heavy that you can't carry them around by hand. And even these are much more limited, obviously, than anything we see in Star Wars. Plasma, again, is difficult. If you were to shoot plasma, I don't know how you would keep it in a coherent beam the way the blaster fire is in Star Wars. I don't think that would really be possible. You could get a blob of plasma, and it could be pretty dangerous. Propelling it at high speed would be a little bit of a challenge. You could use electromagnetism, and that would help a lot. But again, unless you had some way of containing a very tight, narrow magnetic field through which the plasma would travel, I don't know how you would maintain its shape. And plasma, once it leaves the source of its energy, loses energy very, very quickly. It starts to cool down immediately. So it would not be a very destructive force for very long once it left that source of energy. So again, an element of fantasy, but still pretty fascinating. Now, this takes us to another iconic piece of technology within the Star Wars universe. It's no moon. It's a space station. Talking about the Death Star. Dr. Johnson did some calculations to determine how much energy the Death Star would have to emit in order to destroy a planet. And he did this by comparing the amount of damage it would need to do to destroy something like Alderaan, which, spoiler alert, if you haven't watched episode 4, it gets blowed up. He said, well, let's take a look at the largest collision we have on record of anything, and that would have been a fragment of the comet Shoemaker-Levy 9 when it collided with Jupiter. And according to Dr. Johnson, to match the power of that impact, the Death Star would need to fire a beam of 3 times 10 to the 45th power photons with an energy level of 1.12 times 10 to the 27th power joules, which is about the same amount of energy that our sun emits in 3 seconds. Or, as he points out, if you were to take the average consumption rate that humans set in the year 2013, it would take 3 million years of human consumption to equal that amount of energy. So it's a massive, massive amount of energy. That's way more energy than we could manage to generate at this point. And it brings to question, what the heck was the Empire using as an energy source for the Death Star? At least for Starkiller Base, we know that it was siphoning power off of a nearby star as well as the core of a planet. And together that could provide an enormous amount of power if you could actually figure out how to do that sort of harnessing. But for the Death Star, I guess they just have a whole lot of coal. Honestly, I have no idea what the energy source was supposed to be, but it's phenomenal. And he also points out that that's just the energy requirements of the laser itself. If you wanted to build the Death Star, That would require more energy than we've ever expended in our history as well, because you look at the size of the Death Star, you then start to figure out how much material you would need to build the thing, how much oxygen you would need to fill it so that people could live inside of it. And those numbers start adding up pretty quickly. Just getting stuff into space takes an enormous amount of energy. Now, you could get around that a little bit by having some form of construction point out in space itself. So in other words, instead of constructing stuff on a planet, sending it up into orbit, and then assembling it out in space, if you had all of your operations out in space already, maybe you're mining asteroids for raw materials, maybe you have a manufacturing facility with 3D printing capabilities that's in orbit around a planet, that would cut down on some of that energy requirement. But in the real world right now, we don't have that, not on a scale that would be anywhere remotely close to being able to build something like the Death Star. Still, I thought it was really fascinating to kind of look at some actual numbers, extrapolated from what we know based on the information that's in the movies and some from the expanded universe. Well, that just covers some of the basic iconic weapons of Star Wars, but we've got a lot more to talk about. And before I jump into those topics, let's take a quick break to thank our sponsor. With exponential knowledge and technology, you can realize exponential outcomes. This is you to the power of IBM. Find out more at ibm.com/you. All right, we're back. So let's talk a little bit about some of the ways that people use to get around in the Star Wars universe, largely space travel technologies, because that's obviously something that we have experience with in real life too. We have gone up into space and we've seen that the Earth is round. Just throwing that out there. No reason. And there's lots of different ways of doing it, and we've even seen several different ways in the Star Wars universe. Again, it doesn't tend to go into much detail because it's not important for the story. The story is not about how did we build an engine so that we can go out into space. It's more about, here are the different points of interest and let's get our characters from point A to point B. However, there are some things we can definitely talk about. For one thing, there are ion thrusters and ion engines in Star Wars. That's typically what they refer to as the engines that get them around between planets. It's when you're not in hyperspace, when you're just traveling at what Star Trek would probably refer to as impulse power. You're going on impulse drive. Well, an ion engine is a real thing. We have ion engines. And just as I said with plasma being an ionized gas, an ion engine gives you a clue as to what the actual working element is here. An ion engine throws out charged particles. That's how it generates thrust. Now, engines in general, this is kind of how they work, right? You have to generate forward momentum, you've got to throw something out the back, right? It's that good old law of thermodynamics. You need to have something going out the back so that you can move forward. In the case of ion engines, we're talking about charged particles, atoms. So you apply an extremely high voltage to some sort of atomic substance, some sort of collection of atoms that you have at your disposal. And that creates this ionized substance that you can then direct out through a nozzle, essentially a thruster. And by ejecting that, you create thrust. Now, keep in mind that these are atoms that you're throwing out there. So if we remember that force is mass times acceleration, you can throw them out really, really hard, right? But they are very, very tiny. They don't have a lot of mass. So because they don't have a lot of mass, they don't impart a lot of momentum to something like a spacecraft. They do generate thrust, but it's not like you go 0 to 60 instantaneously. It's more like you go 0 to 60 within hours or days, depending upon the size of the thruster you have, the amount of mass you're trying to push, and how much material you're throwing out of the thing. So you would need lots and lots and lots of atoms to make it work the way it works in the Star Wars universe. But it would work. You could have ion engines. It's just that you wouldn't accelerate nearly so quickly. You would continue to accelerate well beyond what you could use with chemical rockets. Chemical rockets, you burn through that fuel pretty quickly, and then you're going as fast as you were able to accelerate to, but you're never going to go faster than that unless you go within the gravitational pull of some other body. With ion thrusters, you can just, as long as you still have atoms to ionize and throw out the back of the engine, you can continue to accelerate. And you could do this over the course of years or decades, getting up to extremely high speeds over a long time. So you would not have a fast rate of acceleration, but it would be very steady, and it would continue until you were reaching the relative speed of what you were firing out the back, once you reach that equilibrium. So you could go really wicked fast eventually, but it's that eventually that is the problem. It means that you better not be in a hurry to get where you're going. Also, ion thrusters are really good for traveling vast distances where you don't have this crushing deadline that you have to be there absolutely overnight by tomorrow. It is better for if you're sending a probe, let's say, out to a distant planet in your solar system, and you want to be really conservative with the amount of fuel you have to use, the amount of energy you have to use. An ion thruster is an ideal way to do that. But in the world of Star Wars, it doesn't make a whole lot of sense because there's also hyperdrive. And if you have hyperdrive, and you're talking about long distances, hyperdrive is way better at getting you far away very fast than an ion thruster would be. So while ion thrusters are real, we actually have built them and we have used them, they do not work the way they work in Star Wars. Now, there is a related technology in Star Wars that also uses ions. That would be ion cannon. And the first time you see ion cannons in use, in fact, it may be the only time, is in Empire Strikes Back during the Siege of Hoth. Hoth being the ice planet that the rebellion has set up base on. And so you've got the Imperial forces gathering around, and on the surface of Hoth, they start turning these enormous guns, these guns that are on giant turrets, toward the sky, and they start firing off ion beams. And in the Star Wars universe, an ion beam doesn't cause physical damage the way a blaster or a lightsaber would. Instead, it overloads electrical systems. So it shuts down electrical systems. It'll shut down computers, it'll shut down shields, it'll shut down navigation equipment, all that sort of stuff. So it works in a similar way to what an electromagnetic pulse, or EMP, would do here on Earth. It doesn't really stretch the imagination too far. If you're talking about an ionized material, you could presumably run a very strong electrical current. You could apply a very strong voltage to it and therefore overload any electronics that happen to be within that field. But we don't really have anything that could do this as far as an actual cannon goes. If you wanted to talk about an electromagnetic pulse, we have covered that in TechStuff before. But to give you a brief overview of what that would be like, typically, this is something that you would find in the wake of a nuclear explosion. So nuclear explosions, they're bad. It's not great. They'd cause an enormous amount of damage. But on top of the immense devastation they can wreak in the point of explosion, they also generate these massive electromagnetic pulses that can cause a lot more damage further out. In 1962, there was the testing of a nuclear bomb that ended up affecting the electrical systems of Hawaii, which was miles and miles and miles away from the testing center. But they had their traffic lights going out, they had car alarms going off, they had all sorts of stuff happening. Well, burglar alarms, not car alarms. It's 1962. And if the same sort of warhead had been detonated over the United States, it would have been enough to cause power grids in numerous states to overload, and that could lead to not just power failures, but fires and other things. Electromagnetic pulses go essentially in 3 phases. You have the first phase, E1. That's where you get a big release of gamma radiation. This would be from your nuclear warhead. Gamma radiation's terrible. You don't want to get hit by it. You will not turn into the Hulk. Don't go seeking gamma radiation. This would also induce within electronics an enormous voltage well beyond their capacity to handle it. So this would fry a lot of electronics right off the bat. The next phase is E2. This is essentially the same effect as being hit by a bolt of lightning. And even if you have your electronics on surge protectors, which would normally insulate them from a lightning blast, the effects of E1 are probably so severe that there's no more protection left. And so anything that was not fried by E1 is definitely going to get fried by E2. Then you got E3, which is more of a distortion of the magnetic field. It's just kind of like a temporary experience where the magnetic field around there is all twisted up. And so it would be like if the Earth were being hit by a magnetic storm, like a solar flare. So that's also can cause some problems with electronics, but after the first 2 waves, you're probably already as bad off as you're going to get. Maybe further out, the magnetic distortion would be causing more of an issue. It is not good. We don't want it to happen. It would cause massive amounts of damage. Moving on from ion cannons and ion thrusters, let's talk about solar sails. I forgot that solar sails were even a thing in Star Wars because they pop up in the prequels. Count Dooku has a solar sail on his spacecraft, and I try not to think about the prequels or Count Dooku at all costs. However, for the purposes of this podcast, I was forced to do it. Shame on you. But solar sails themselves are pretty awesome. A solar sail uses the momentum of photons to move a spacecraft. So whereas a sail on a sailing boat captures wind, a solar sail is a large reflective surface upon which photons can bounce and thus transfer momentum to a solar sail. Now, that sounds pretty awesome, but it also raises some questions. For example, photons. Photons are particles of light, but they don't have mass. Momentum, however, is defined as P equals m times v. Now, P stands for momentum, m stands for mass, and v stands for velocity, which is, a vector. Velocity is a speed and a direction. So photons will have speed and a direction, but they don't have mass. So how can they possess momentum? If you've got a particle that has no mass, how could that possibly push against anything? Well, photons do have momentum, but it's relativistic momentum, photon momentum. We define that as an equation of Planck's constant divided by the photon's wavelength. All right, that gets a little complicated. So first of all, a photon's energy is equal to Planck's constant times the frequency of the photon, which is measured in hertz. Planck's constant, by the way, is 6.63 times 10 to the 34th power. Big number. So you've got the momentum, which is Planck's constant, divided by this photon wavelength. That tells you, by the way, that different colors of light have different relativistic momentum, right? Because wavelength, that's what determines the color. And the difference being that if you've got, wavelength of one size, you're going to actually have more momentum than another. It really tells you how much energy each wavelength of light has. So red light has lower energy than blue light. That's an easy way of thinking about it. Now, each photon can only transfer part of its momentum to the actual solar sail. So you're talking about a minuscule amount of momentum being transferred by a massless particle to this large reflective surface that's usually incredibly thin. I mean, thinner than a sheet of paper, if you really want an effective solar sail, and it has to cover a massive amount of area. If you're pulling a human being, you're talking about something like the equivalent of 5 miles of material. That's a lot of material. It's a huge solar sail. Also, the way it's done in Star Wars, it looks like this big curved sail. You wouldn't want a curved sail. You want a flat surface. The reason for that is if you have a curved surface, some of those photons are going to be hitting that at an angle, which means it's not really pushing the spacecraft forward. It's pushing a little to the left or a little to the right, and those left and rights are canceling each other out. It's just wasted energy. You would prefer to capture as much of that giving you forward momentum as possible. It does, however, mean that whatever direction you're facing, you better want to go that way, because you don't really have a whole lot of opportunities to change your direction. The reason why this is an effective means of getting around in space is because if you have a steady supply of photons, while every individual photon is barely able to transfer any momentum to your spacecraft, there are trillions of the little suckers, and they're constantly hitting that surface. So just through the quantity alone, you will continue to accelerate. You'll do it very slowly. So using a solar sail, again, like an ion thruster, is not going to get you up to super fast speeds right away. But over the course of many, many years, you'll get pretty darn fast. Now, you may remember that there was this work being done on tiny little satellites that are launched into space. They're going to use solar sails to propel them toward Alpha Centauri. And over the course of several years, they will get up to a speed of about 20% the speed of light. And while it would take us a really long time to get by Alpha Centauri if we were using chemical rockets, it would take us hundreds of years. With a solar sail, we can get there within about 20 years. And the payload they're pulling is these tiny, tiny, tiny little satellites. It's essentially nothing more than a camera and an antenna to send data back to Earth, and that's it. So it's very small, and that's why it's a viable technology for that particular application. But for Count Dooku to go zipping around the galaxy, not so much. It wouldn't work the way it does in the movies. Sad to say. That brings us to hyperdrive. And boy, howdy, is this a tough one to talk about. So hyperdrive tries to get around the big problem of getting around a galaxy that is many light years across in a reasonable amount of time. Because according to Einstein's observations, and this has been borne out by all experimentation up to this point, the speed of light is as fast as you can go in our universe. And we assume that Star Wars is taking place in our universe. It's just another galaxy within our universe. So you can't go faster than the speed of light, and yet things might be several light years apart, which means it would take you, even if you could go as fast as light, and anything with mass can't, but let's say that somehow you found a way around that, you would still take several years to get to your destination. That's not great if you want a rollicking adventure in space, where a farm boy takes down a militaristic empire. You need something to get around that. That something is hyperdrive. Now, in the world of Star Trek, the way they get around this is using the warp drive, and warp drive warps space-time itself. You can think of space-time as being this kind of three-dimensional, really four-dimensional soup around us, and it conforms in some ways to all the objects that are present within that space-time. We warp space-time. You are warping space-time right now. Not on nearly as grand a scale as something like Jupiter or the sun, but you are warping space-time. If we could control that and warp it in such a way that we're effectively making a distant point closer to us, we can still travel at a reasonable speed and get to that destination faster, not because we're moving faster, but because we've pulled that point closer to where we are. That's the concept behind warp drive. Hyperdrive is kind of similar, but even more vaguely described. Hyperdrive is supposed to open up a pathway through extra dimensions that we normally don't have any contact with, and using that extra dimension, creating a shortcut between points A and B. and it relies very heavily on computers to make the calculations necessary to go into and come out of hyperdrive in a safe way, so that you arrive at your destination at a reasonable distance and you don't appear, say, in the middle of a star or a supernova, as Han Solo would say. So it's not like dusting crops back home. You have to have that calculation. You have to have this way of entering into these extra dimensions, and we don't have anything remotely capable of doing that. We have lots of theories that require extra dimensions that we cannot ourselves observe. You may have heard of string theory. String theory essentially says that everything in our universe at a level even smaller than subatomic is made up of strings, and those strings are either lengths of string or loops, kind of like a rubber band, and they're all vibrating at different frequencies, and the way they vibrate determines what they are, like is it an electron or a proton or whatever it may be. String theory, some of them suggest that we would need as many as 26 dimensions in order for the theory to work. And there's nothing that we can do experimentally that can tell us whether or not we're on track. They're not falsifiable. In other words, in science, there's an important concept called falsifiability. So for something to really be considered scientifically valid, it has to be falsifiable, meaning there has to be a way where if you were to test it, the outcome could be otherwise, and that would tell you, all right, well, now we know that this is that way because every time we experiment, it turns out this way. But if it didn't turn out that way, it would be false. String theory is not falsifiable because it's not testable. We cannot test it in any way. That doesn't mean it's wrong. It just means we can't know that it's right because it's beyond our capability of even exploring, which is kind of cool in a way, also frustrating because you might argue that's more of a philosophy than a science. However, the math is pretty awesome. It also is well beyond my ability to understand. Some of those mathematical models require these extra dimensions. So hyperdrive would in some way be able to tap into that. That is so far beyond our capabilities that it really is the same as saying you could summon a magic dragon and it'll teleport you to where you need to go. It's about the same thing because there's not really any way that we can physically accomplish what we see in Star Wars in the real world. But at least they were trying. They weren't trying to go faster than light as such. They were trying to create shortcuts in space-time, at least according to most descriptions of hyperdrive. Again, in the movies, it doesn't really go into that detail. It just, you know that hyperdrive is very fast and you know it's very dangerous based upon the limited amount of information spoken in the Star Wars films. And the last thing I want to talk about in this section is the concept of super maneuverability. And Dr. Johnson actually brought this up in his book, and I thought was pretty fascinating. This idea that there are times where you see vehicles in Star Wars behave in ways that are beyond the capabilities of what the craft normally would be able to do based upon its design. So in other words, if you build a plane and you've got a certain wing design, certain chassis design, certain engine in that plane, there are going to be some things that plane can do, and then there'll be things outside of that that the plane cannot do. But in the Star Wars universe, there's occasionally moments where vehicles are able to do something that is outside of what they typically should be able to do. Dr. Johnson actually talks about the possibility of creating systems that would allow us to do this. And in fact, we have done this with military vehicles where by adding in extra technological elements, you can create a extra maneuverability capability of your vehicle. So an example he gives is adding paddles to thrusters for jet engines. So in other words, you can use paddles to help redirect the thrust that's coming out of a jet engine. Because the direction of the thrust determines what direction the vehicle goes in. If you're throwing thrust immediately behind you, you're going forward. If you start throwing thrust to the left, you'll start moving to the right. By using paddles to redirect thrust, you can add to the maneuverability of a vehicle within a certain range of parameters. Obviously, if you go beyond that, you could start to cause structural damage to your vehicle, and that's not good. So one of the examples Dr. Johnson gives is of a vehicle, a plane, a jet, that has the capability of hovering with its nose pointed nearly straight up because of this ability to direct the thruster, which doesn't sound terribly comfortable, but he points out that the capability was designed so that if you're in this type of aircraft and you have an enemy aircraft behind you and it's trying to chase you down and shoot you, you could use this maneuver to come to what is essentially a complete stop in the air, have your enemy aircraft fly past you, and then now you're behind it, and the tables have turned. So there are some elements of the technologies in Star Wars that we do have in our real world. And in fact, there's some that work much better in the real world than in Star Wars because they rely upon planetary physics, not interstellar physics. So you might see things like planes banking in Star Wars, or not planes, but starcraft banking in Star Wars, like X-Wing fighters and TIE fighters. Obviously, that's not really possible in space where you don't have an atmosphere to bank off of, but it does work here on the planet Earth. Also, TIE fighters, what a weird design. Their wings are vertical, not horizontal, so that means they wouldn't actually generate lift as they move through the air. They'd work fine in space, I guess, but once you got them down to an atmosphere, I'm not sure how well they would perform, unless you were to fly it sideways, and even then, that'd be a little weird. Well, I've got a lot more to say about a few more technologies that are in the Star Wars universe, but before I jump into that section, let's take another quick break to thank our sponsor.
Hey, my name's Jack. I'm the founder and former editor-in-chief of Crack.com and the host of the new How Stuff Works comedic news and pop culture podcast, The Daily Zeitgeist. Our goal is to tell you about the ideas that are out there changing the world. We talk politics and news, but we also cover supermarket tabloids, which might seem stupid, but millions of people pass those every day, and they absorb the ideas on the cover whether they want to or not. We also take movies pretty seriously because when we picture something that we haven't experienced, you generally use movies. You probably picture Terminator 2 when picturing a nuclear explosion, even though that's not actually what they'd look like. Anyways, we're trying to take the temperature of what's affecting the national shared consciousness, which sounds a little more hippie-ish than we actually are. But fair warning, guys, some of the content can get a little edgy, so not for young ears, but trust us, it's all in good fun. So go to Apple Podcasts and listen and subscribe to The Daily Zeitgeist. It's very good, is our catchphrase. We're kind of workshopping it.
Okay, so I talked about how vehicles attempt to get around in space in Star Wars. There's also terrestrial vehicles. Stuff not meant to go into space, in other words. I think I was channeling Chris Paulette there for a second. So you've got things like Luke's land speeder in A New Hope. It travels by levitating above the ground, and obviously that has some really cool benefits, right? You don't have to worry about a rocky path that you're traveling down. You're actually floating above it. So it's a nice smooth ride. You don't have the friction of the ground to fight against, so you can accelerate very smoothly, get up to a nice top speed. The question remains how you do that, because gravity is a harsh mistress, as the Tick once observed, and boy was he right. So how would anti-gravity work? How do the repulsor lifts in Star Wars work? That's a good question because it's not really ever addressed. And obviously other vehicles are able to do this too. When the Millennium Falcon takes off, its thrusters are all located in the back of the spacecraft, but it must have some form of repulsors in order to actually lift off the ground before its ion thrusters kick in. And there are a lot of interesting questions about this. I mean, gravity is one of the fundamental forces of the universe, is one that we understand the least about. We can incorporate the other three fundamental forces into a unified theory, but gravity eludes us. We have not yet figured out how to incorporate that in a unified theory. And while we use a lot of language to talk about what gravity does, it's mostly placeholders. Like we talk about gravitons, that again is more or less a placeholder for the thing that is able to actually enact gravitational pull upon things. We know what gravity does, right? We know that it's a force that attracts all objects toward one another, and that force is dependent upon the mass of the objects in question and their relative distance to each other. So the further away you are from something, the less of a gravitational pull you will experience from that thing. But technically speaking, every single object in the universe is pulling gravitationally upon every single other object in the universe. It's just that in most cases, that pull is so faint as to be completely undetectable. But when you get into distances and masses that are substantial enough, you can get this actual gravitational pull. So, for example, a planet and you. Earth is massive enough and you're close enough to it where you are going to be affected by its gravitational pull, and that's why you're not flying off into space. I presume you're not flying off into space. If you're an astronaut strapped into a rocket and you're about to go to the space station, you are about to fly into space, and I salute you. But for the vast majority of my listeners, I suspect that they are not about to fly off into space. Well, Dr. Johnson actually has a suggestion for how a repulsor lift could work, assuming that you're not using some sort of maglev approach, which I'll talk about in just a second. And that is, again, bending space-time, which seems to be a bit of overkill to me, but let's run with it. He says that if you were able to remove the bending of space-time around an object, you could levitate it. And like I said before, space-time bends around everything. So if you could remove that around an object, you could have it where it just floats in a very specific way above whatever surface you were concerned with. But you would have to make constant adjustments for this. Every little tiny change would possibly result in capsizing your vehicle. You would have to have an incredible system that is able to sense these changes dynamically and respond instantly so that you would have the proper balance the entire time. Otherwise, you would just end up having an object that would flip around and then crash, and that's not great. Now, I did mention Maglev vehicles. They work on a principle that is similar to what we see with repulsor lift vehicles in Star Wars, but they require very specific parameters. You can't just run a Maglev vehicle over any surface. It has to be over something that's generating a magnetic field. So this is how a lot of Maglev trains work. Typically, you'll have a collection of magnets. Some of them might be permanent magnets. Some of them might be electromagnets. So let's say in the train, you have some permanent magnets set up on the base of your train. And then in the tracks, you have electromagnets. And the electromagnets are generating a magnetic field that's in the same polar alignment as the magnets that you have permanently affixed to your train. So you've got the similar poles facing one another, North Pole to North Pole, or South Pole to South Pole. Now, if you've played with magnets, you know that those same poles will repel one another. North repels north, south repels south. Opposites attract one another. So if you have the magnets repelling one another, you can actually create a force strong enough to push the train up, to levitate the train above the tracks. And there are maglev trains that do this, that use electromagnetic force and magnetic fields to create this form of levitation. They'll also use electromagnetic force to propel the train. Typically, you'll use a system that is switching poles rapidly, and you really can do this just by using alternating current through an electromagnet. You reverse the flow of electricity that flips the magnetic field. So if you do it so that the opposite charge is just in front of the train, it pulls the train forward, and the same charge is just behind the train, that pushes the train forward. And this push-pull, if you keep flipping those poles over and over and over again, you could make the train accelerate pretty darn quickly. This is, of course, the basis for the transportation systems that have been proposed for Hyperloop, using electromagnets to create that motive force. Although the Hyperloop doesn't necessarily use maglev as the way of getting above the ground. The initial Hyperloop presentation that Elon Musk talked about was one that would use air skis. So the actual vehicles would use pressurized air pumped downward to create lift, and then use electromagnets to create the motive force to move down the track. Other Hyperloop designs actually do use maglev technology. They avoid the air skis approach that Elon Musk had suggested. So maglev does exist, but again, you can't just use it anywhere. This has to be, first of all, the tracks are set up in such a way where the train's not going to get unbalanced and fly off. You know, you have to have that barrier system there to hold the train in place where it's going to levitate up, but it's not going to fly off the track one way or the other. It does, however, remove that amount of friction that you would get with wheels making contact with a rail. So you do reduce the friction that you would encounter otherwise. So there are systems out there that are like that. But again, you can't just drive it over anywhere. You can't drive it over the desert like the land speeder does, because you don't have that magnetic field to push off against. So that wouldn't really work. One other thing you could do, and again, this requires a magnetic field, but it'd be super awesome if you could do it, is you could use superconductors and use superconductor levitation. You may have seen videos of this. It's one of the most counterintuitive things to see. Like the first time I saw it, I thought, what sorcery is this? It must be trickery. Someone must have gone in and done some sort of digital video shenanigans. But no, it's actually a relatively well understood phenomena. Superconductors can levitate in the presence of a magnetic field. They can actually maintain an orientation relative to that magnetic field, and they won't change it unless you actually change their orientation. So the way this typically works is that you get a superconductor, you have to chill it. Superconductors typically are only superconductive when they are very, very cold. Superconductive means there's no electrical resistance of the materials. Thus, you have superconductor. A conductor allows electricity to move through it, but typically you have resistance, and that means you lose some energy in the form of heat. The material will heat up as this resistance is there. And you can reduce resistance in various ways, but superconductors, once you chill them to a certain amount, and we're talking super cold, you're usually using liquid helium to get them cold enough, they will conduct electricity with no resistance, and they have this other facet, this flux pinning levitation. So you get a superconductor that's cooled down to this level, you got it over a magnetic field, it'll just hold its position there over that magnetic field, and you can even tilt it in different ways, and it looks like it's just stuck in midair. It's fascinating. If you have a round magnet, so you've got a magnetic field that's in a round, like a track, you can even give it a little push, and it'll just spin around and around that track. And again, what seems like magic. It's fascinating to watch, and there are tons of videos about this phenomena on YouTube. So if you've never watched one, I recommend you do it. What's going on here is that when you supercool a superconductor, once it reaches a certain temperature, I think minus 211 degrees Fahrenheit is the warmest we can get right now, but that's actually much warmer than what it used to be. You'll actually see it reject all magnetic fields. So it's like it's expelling magnetic fields. And that allows you to put it into whatever orientation you want within another magnetic field, and it'll just hold it there because it's not allowing anything inside. It's just kind of stuck. Obviously, you can't really do that with a vehicle. You would have to have the vehicle components chilled to an incredible amount. That means you have to haul around a huge amount of liquid helium or liquid nitrogen, probably liquid nitrogen first, to cool it down enough to then switch to liquid helium. If you use liquid helium right away, you're just going to shatter whatever your technology you're using. And you would still need a magnetic field to float above, so you couldn't just do it anywhere. But still pretty interesting. So again, repulsors probably not terribly practical in the real world. Dr. Johnson also addresses another thing that I wish never existed in the Star Wars prequels. I'm talking about pod racing. Pod racers, first of all, it really showed that George Lucas loves car racing a lot, which we all knew. If you know anything about Lucas's past and his childhood experiences, you know that he was really big into hot rods. He loved fast cars. And pod racing is nothing but a real long car racing sequence in The Phantom Menace. But how would that work? I mean, the way the pod racers are set up, they look like they are cockpits that are tethered to free-floating engines, apparently jet engines, that then pull the cockpit along. And most of them have 2, some of them have 4. One of them is more like a jet engine rocket that one of the characters is riding on top of, but the rest are being pulled by either 2 or 4 jet engines. Jet engines, not the safest things to be around. In fact, if you ever worked around jet engines, you know there are 2 danger zones. And I don't mean like the song. One of them is directly in front of the jet engine, the intake, because you could get sucked into it, and that would be bad. And the other is directly behind the jet engine, where you could get hit by hurricane force winds. When a Boeing jet engine is idling, it's idling at a speed that is equivalent to a Category 3 hurricane. When it's actually thrusting, when it's putting forth thrust, that's talking about a Category 5 hurricane. That's strong enough to knock over a house. We're talking about more than 155 miles per hour winds at 100 degrees Fahrenheit. So it's a hot hurricane blast hitting you right in the face. And you've got 2 of those strapped 50 feet in front of you, pulling you along. Not the best way to get around. What I did love about Dr. Johnson's approach in tackling this was he said, well, would it be possible to build something like this that would kind of work that way? He says, well, if you could elevate it off the ground so that you could get it up to speed to generate thrust so it could take off, and if you added wings to it so that it would have lift so it could counteract the effect of gravity pulling it down, then yes, but then you've just built a jet, because that's what a jet is. And you no longer have a pod racer. Not practical. Also, he talks about the electrical arc that is visible, that exists between the engines. For that to happen, it has to be in a massive amount. Like, the voltage has to be so high that when Jar Jar comes into contact with it, he would have been essentially executed by electricity, and we all would have been spared the rise of the Empire, because as we all know, Jar Jar's the one who voted to give the Emperor the control over the Senate and the executive power that he needed in order to really bring his plan to completion. So the universe would have been spared, but somehow Jar Jar survived. It's really the tragedy of The Phantom Menace when you think about it. So one other thing I wanted to touch on before I conclude is the concept of holograms in Star Wars. They factor in pretty heavily. Character communication is often represented by holograms. Princess Leia has a hologram stored in R2-D2. There's a hologram chess game that's aboard the Millennium Falcon. Holograms are interesting in the Star Wars universe. They appear to be fully three-dimensional creations of light. They can be created by a single projector, because R2 is able to project out this image of Princess Leia fully formed, and then her brother starts creeping on her, which is you. But anyway, we can't really do that because, again, we can't really tell light where to go and make it stop. Typically, if we want to create a hologram-like effect, you need to have something that you're projecting the light against, particles, like a dust cloud or smoke or something else along those lines. Now, you could use different wavelengths of light and different sizes of particles to kind of get an effect similar to what you see in Star Wars, but you wouldn't have very good resolution, nor would you have very good color representation. So it would look more like amorphous light blobs as opposed to three-dimensional figures that seem to have some sort of presence in your area. So holograms, as they are depicted in Star Wars, are not possible. Now, there are a lot of ways of cheating around that. Like I've talked in the past about the Pepper's Ghost illusion, which gives the effect of a hologram, but is not, at least in the sense of what we see in Star Wars, the same thing. Pepper's Ghost, by the way, uses a reflective surface, like a pane of glass. And you typically have the viewer, the person who you want to do the effect on, in darkness. And you have, out of the viewer's line of sight, an area that can be brightly lit. And so then the viewer's looking at a pane of glass. They see a reflection in that pane of glass, but to them it looks like a translucent figure. A lot of haunted mansions use this, including the Haunted Mansion ride at Disney, in Disneyland, Disney World. Whenever you go through the ballroom sequences and you see all the ghosts that are dancing around or at the birthday party or they're shooting weapons at one another, those ghosts are actually animatronic figures that are either below or above the track, which you can't see because you're in a enclosed track that's in darkness, and you're seeing their reflections on a pane of glass. So to you, it looks like these translucent ghost figures, but in fact, they are solid three-dimensional figures that are just out of sight, and you're just looking at their reflections. So there are ways we can cheat to make it look like we have a three-dimensional hologram, and there are some ways that we can make very believable simulations of that, but we don't have the technology to make one the way that we see them in Star Wars. Not to that level. Not to say that we won't ever do that. We may find a way of being able to do it in the future. And we can, like I said, if you use smoke or mist or water and you use multiple projectors, you can get pretty interesting simulations, but it's not quite the same thing. Still, it was fun to go into the world of Star Wars and look at some of the technology there. There's clearly a lot more that we could have talked about. I didn't touch droids at all. We didn't talk about walkers. There are a lot of other things. There are like electrostaves and things of that nature that I didn't even really mention in this episode. A lot of that is covered in the book that I was using as my prime resource, The Physics of Star Wars. Again, that's by Dr. Patrick Johnson. And I do recommend checking that book out if you're interested in science and you like the Star Wars films. It's very easy to understand. It's entertaining. So I recommend that if you want to give this a longer look and explore other elements of science, not just the technology aspects. As for the Tech of series, I love doing these. If there is a world, a fantasy world out there, or a science fiction world out there that has interesting technology and you would like me to cover it, both in the way it's supposed to work within that mythology and the way it would work in our real world, let me know. Or any other topic for that matter. If there's something in tech that you want to know more about, send me a message. Maybe there's someone you want me to interview on the show or have on as a guest host. Let me know that as well. You can reach out to me on email. The address for the show is techstuff@howstuffworks.com. Or you can drop me a line on Facebook or Twitter. The handle of both of those is TechStuffHSW. We also have an Instagram account at TechStuffHSW. Check that out. We've got a lot more stuff coming up on that. So including, I think we're going to end up having some interesting little video snippets and stuff, things that you don't get anywhere else. So check out the Instagram account. And as always, you can join me live when I record these things on Wednesdays and Fridays over at twitch.tv/techstuff. Just go over to that site. You'll see where the schedule is and you'll see when I record. And you can watch live as I have brain meltdowns and become incapable of saying even the simplest words, like my viewers did just moments ago that you didn't get to hear because Ramsey the Wonder Producer cut it out. Thanks, Ramsey. And thank you guys. I'll talk to you again really soon. May the Force be with you.
For more on this and thousands of other topics, visit howstuffworks.com.
You, powered by data, knowledge, insight. That's U to the power of IBM. Enhance the way you do business at ibm.com/u.